Namaste, this is JVN Dr. Vishal Saxena, Associate Professor in Mathematics and Statistics in Jayoti Vidyapeeth Women's University, Jaipur. Today I am going to discuss on the module line of regression and regression coefficients. This module is a part of the course Biostatistics under the program of BSc FND third semester, integrated BTech MTech FBT third semester and BTech FBT third semester of the university. This is part of the lines of regression, and regression coefficient just deals with the concept of the regression. And as all we know that the regression is a very important part of the biostatistics as well as the statistics, and the regression is just related subject to the correlation analysis, and the regression is a kind of the functional relationship between the two variables. So the regression can be defined as a relationship or a functional relationship between the two variables. It can be used to find the trends of the data, and the relationship between the two variables can be determined, the functional relationship can be determined by the equation of the curve, and the lines of regression will also provide the equation, or in the linear form the lines of regression will provide us an equation in a linear form, and which will just give a relationship between the two variables. As it is clear from this word lines of regression, so lines of regression definitely will be in the linear form, and this will when we draw a linear equation, then a line will be drawn, so the regression will be just given by the lines of regression. And here we are going to discuss about that with mathematical concept, mathematical formula, and with the examples. So we are going to discuss about the linear regression today, and this part is important for this program, this course, and just dealing with the lines of regression. Just as all we know that the two lines of regression are there by which the two variables are related with each other. So what are the two lines of regression? The first line of regression is called the equation of the line of regression of y on x, and the second line of regression of x on y is called the line of regression of x on y. And the coefficient of regression, we will discuss about the regression coefficients today. So we take some slides to understand the mathematical concept and what are the meaning of regression coefficients and the lines of regression. So we take some slides to clear it. Initially, the definition of regression analysis is mentioned. The regression analysis is used in statistics to find trends in the data. For example, you might guess that there is a connection between how much you eat and how much you weigh. So there are two types of the concepts and related to each other: how much you eat and how much you weigh. So it means the two types of relationship can be just obtained by the regression concept. The regression analysis can help you to quantify that regression analysis will provide you with an equation for a graph. So definitely a regression will provide us the equation, and if we are just talking about the linear regression, then it will be given by an equation in the linear form, in the 1-degree form, so that we can make predictions about our data. The lines of regressions. So now we have the concept of the regression lines, and the lines of regression. Just we have mentioned that there are two types of lines of regression. One is called the line of regression of y on x, and that is called the line of regression when the y depends on x. So it is called the regression line of y on x. In the similar way, the line of regression of x on y, where the variable x will depend upon y. So these are the two line of regressions, and we can see there a line of regression is written there, y is equal to a plus bx. Y is equal to a plus bx can be considered as a line of a regression of y on x, because here y is a dependent variable and depending upon x. And the two lines of regression can also be written as, now we are having one equation of regression line of x on y. So we can see at bottom there the line of regression of x on y is mentioned there, and it is x minus x bar is equal to r into sigma x upon sigma y into y minus y bar. So this represents the line of regression of x on y, and here the x bar and the y bar are the mean values of two variable x and y. So x bar and y bar are the mean values of two variable x and y, and we can also say that these are the mean values of two series x and y. R is the correlation coefficient between two variable x and y, and the two data series x and y, while the sigma x is the standard deviation of the data series x, and sigma y is standard deviation for series y. The term r sigma x upon sigma y, r sigma x upon sigma y is called, this whole term r sigma x upon sigma y is called the regression coefficient bxy. It is the one of the regression coefficient bxy, and it is given by r sigma x upon sigma y. The second line of regression can also be given by the same formula, by similar to this, like where is the x can be replaced by y and y can be replaced with x. So just the regression line of y on x can be obtained as y minus y bar is equal to r into sigma y upon sigma x into x minus x bar. So that is the second line of regression, and here the regression coefficient is byx, because this is the line of regression of y on x. So the regression coefficient is called byx, small b yx, and it is called r into sigma y upon sigma x, r sigma y upon sigma x. So these are the concept of line of regression and regression coefficients, and we take some examples to explain this, how can we find the line of regression and the correlation coefficient and the regression coefficients. So here this question is given that, this example is given that find the mean values of x and y of the two series, find the means of the x and y variables, and the coefficient of correlation between them from the following two regression equations. So these are the two regression lines given that, and the x and y are the two variables. Now when we solve these two equations, these are the two linear equations, and when we solve these two equations, then we will get x equal to 130 and y equal to 90. As all we know that the mean values x bar and y bar will satisfy the regression lines. Therefore, these values of x and y will also be the values of x bar and y bar. So that means x bar is equal to 130 and y bar is equal to 90. Now next, to find the correlation coefficient and the regression coefficients, we have to just consider the two given line of regression. One is of y on x and second is the line of regression of x on y. So the first equation, suppose that the regression line of y on x. So here it is 2y is equal to x plus 50 and y is equal to x upon 2 plus 25. So that is the line of regression of y on x, and this 1 upon 2, which is slope here, this slope is the regression coefficient b by x. It is the regression coefficient b by x, that is the slope half of this line y equal to x by 2 plus 25. In the similar way, the second line of regression is 3y minus 2x minus 10 equal to 0, and solve this equation for x. So this is the line of regression of x on y, and this becomes x equal to 3 upon 2y minus 5, x equal to 3 upon 2y minus 5, and here the slope 3 upon 2 is there, and that is the regression coefficient bxy. The regression coefficient bxy means the regression coefficient of line x on y, that is bxy, and it is equal to 3 upon 2. And as all we know that the regression coefficients, the product of regression coefficient, the under root of regression coefficients is equal to correlation coefficient r. So r is equal to plus minus some under root bxy into b by x, and that is equal to 1 upon 2 into 3 upon 2, and that is equal to 0.866. Now here r is taken positive because this is the property of regression coefficient, that all the coefficients, like the two regression coefficients and the correlation coefficient r. So the three coefficients, one is correlation coefficient and the other two are the regression coefficients, will have the same sign. That means either all three are positive or all three are negative. That means because here byx and bxy are 1 by 2 and 3 by 2, and these are positive, therefore r is also taken as positive, 0.866. So the regression coefficient is 0.866 positive. Now we take another question here to understand this. The following table shows the sales and advertisement expenditure of the firm. Here the mean and the standard deviation are given, that for the sales and the advertisement expenditure. Coefficient of correlation r is equal to 0.9. Then estimate the likely sales for a proposed advertisement expenditure of rupees 10 crore. So these are the mean and the standard deviation of the sales and the advertisement expenditure are given that, and now we solve this problem. So let the two terms, one is here the sales and the other is advertisement expenditure, are taken as the two variables, x and y. So we are given that x bar equal to 40 means mean, y bar equal to 6, sigma x means the standard deviation of series x, that is 10, and sigma y equal to 1.5 and r equal to 0.9. So here the first variable x is taken as sales and the advertisement expenditure is taken as y, and we are given these quantities. Now taking the regression line of x on y, so we are taking the equation of regression line of x on y, that is the x minus x bar equal to r sigma x upon sigma y into y minus y bar. Now putting all these values and then we will get x equal to 6y plus 4. X equal to 6y plus 4. Now according to question, what is required in this question? In this question we have to find if the advertisement expenditure is 10 crore, then what would be the value of sales. So we are taking the value of y is equal to 10. Y is equal to 10 and then we have to find x. So x will be equal to 6 into 10 plus 4, that is 64. So it means the 64 will be the value of sales when the value of advertisement expenditure is 10 rupees 10 crore. So in this way, in the today's session we have discussed about the regression analysis, the lines of regression and regression coefficient. With this I conclude my today's session. Thank you.